Hi, welcome to the virtual JBug. Today we're going to be talking about creating JavaEE microservices with WildFly Swarm. And for today's presentation, we've got Bob McWhirter, who's the co-founder of the WildFly Swarm project. So now I'll hand over to Bob, who can introduce himself in a bit more detail and kick off the talk. So, thank you very much, Bob. Thanks for coming.
Thank you, Paul, for having me. Yes, I and Ken Finnegan founded the WildFly Swarm. I'm gesturing this way because Ken's in the audience, along with most of the Swarm team. So, WildFly Swarm is all about microservices. We'll jump into this. It's sponsored by Jboss. And so let's first address what microservices are. And y'all can read all the words here. But generally, a microservice is trying to decompose your application into small pieces. That's okay, we can wait. Decompose your application into small pieces where each piece has a very small bounded context in which it operates, so that you don't have tightly coupled code, you have lots of little loosely coupled pieces of code. Microservices is good because you can deal with multiple languages. Single artifacts that you can deploy just by themselves. It's not a matter of having your app server over here that you then throw a WAR file into. It's more along the lines of having a jar file that you just run. It's just a single artifact. And the good thing about that is I build on my laptop and I run this thing. It's great. I hand that same thing to QE and they're running the same bits and they test it, and that's great. And then when they approve, they hand that same thing over to your production people or your DevOps guys, and they run it, and that's great. For scalability, if we have 20 microservices out there to make up your application, and 2 of them are really overloaded, and the other 18 aren't, if we're dealing with an app server, you got to scale up the whole thing, and you got 10 nodes of this app server. But with microservices, you can leave 18 of those alone and take the 2 that are overloaded and deploy more of them and scale out just the bits that you need to scale out. And configuration, I'm not quite sure why this is on the slide, Lance.
Well, it had to do with the fact that if you're deploying in an SOA type of environment, typically you're deploying to an application server that has a configuration file like Standalone.xml, and if you're deploying little pieces into that server over time, configuration for one bit of the application may conflict with configuration for another bit of the application, and you may not be aware of it until you get it into production. Whereas with microservices, the configuration is either already just built into the product itself, or the thing that you're deploying itself, or even if it's not, it doesn't necessarily conflict with the configuration of a much larger sort of application server, where you might have other things running at the same time.
Good job. That was the answer I was going to give. You get an A. So yes, configuration. So single artifact deployment we discussed, independently, continuously deployable. Continuous deployability is one of the big things here. Is that with a monolith, you tend to have a release cycle where, all right, everyone gets together and every 6 weeks or every 2 months, you release the application, right? And maybe you stay up all night waiting for things to break while you get it deployed. And with microservices, you're dealing with much smaller little pieces. And each of these pieces could have its own release schedule. And Amazon has what they call the 2 pizza rule, which is any service should be able to be written by a team that can be fed with 2 pizzas. And so we're dealing with these small little teams and small little services, and the teams define their release schedule. And so I can continuously deploy this. I decide, all right, my particular service, I need to update something. I found a better way to do it, or a more efficient way to do it, and I'm going to deploy it. You know, I don't have to wait till the whole app is ready to deploy out there in production. I'm sure y'all have read like the GitHub log posts where they deploy like 74,000 times a day or something, because they're always just rolling new code out there, and there's no longer the big bang kind of deployment. And this is key also when you're doing CI/CD, continuous integration, continuous deployment. So I make a change to my code, the Jenkins builds it, and then it gets packaged up and sent out to the production, and it works. You know, that's great. So you're no longer waiting for these big bang deployments. Scalability, just talked about that. Hey, this is the slide, Lance. I should have seen that one. Okay, so a typical WildFly deployment, because this is a talk about WildFly Swarm, which is kind of a way of talking about WildFly, but different. So a typical WildFly deployment is you do have your app server. You go download WildFly 10.0, point final or whatever, and you unzip it. And you end up with this directory full of WildFly stuff that you can start and it does nothing. You go to localhost 8080 without deploying anything and there's no connection, nothing's there, right? So then you take your application that you've used, maybe some JaxRS and some JPA, and you put it into your WildFly, and now you have your app running inside your app server. But you also have an app server that's giving you bean validation and transactions and EJB3 and JMS. All these things are things you haven't used, but you're paying the price of having them on disk and for having the app server running and an orb sitting out there ready to do JTA or whatever. And you don't need this, right? Because your app only uses JaxRS and JPA. These are unused. This is wasted space and effort, and I don't know. You just don't need it. Why do we ever need to have anything we don't need? We don't. Okay, but how do we do this with WildFly Swarm? First, some terminology. You may have heard it called a fat jar. We like the term uber jar, which is where we take the bits of WildFly you need. Not all of WildFly, just the bits you need, the JPA, the JaxRS in this case. And we take your application, maybe a WAR file or whatnot, and we stick them in a blender, and we pop out an uber jar that you can do java-jar this uber jar thing, and it runs. And it has all of your WildFly that you need, and it has your application, and it's this one thing, and now I can stick this thing in an email and send it to Lance, and he can run it without having to change a standalone XML, without having to download WildFly and unzip it and put this app into it. It's basically an executable jar file that has everything you need. WildFly Swarm has this idea of a fraction, which is what I keep talking about, the pieces of WildFly that you need and none of the pieces you don't need. Well, each of these pieces is a fraction of WildFly. We have a pie that is all of WildFly, cut up into 10 slices or 22 slices or whatever, and sometimes you want just a fraction of it. Roughly these map to subsystems, if you're familiar with WildFly. We have JPA subsystem, we have an undertow subsystem, but we also get extra things through fractions. Since WildFly Swarm is new development, we can bring all sorts of new things in here. So you're like, all right, I want to use JaxRS, but I also like Netflix Ribbon for doing client-side load balancing of network calls to other RESTful services because I have this whole flock of microservices out there. Or I want to have Jalakia installed in every service. So we've kind of wrapped fractions around all these things. And so you define which fractions of WildFly and this other stuff you want bundled up with your application. And we make the uber jar that we talked about on the previous slide from all these fractions of WildFly in your application. So subsystems, deployments like Ribbon Web App and Jalakia, you can even alter deployments. So let's say I have a WAR file that I want protected by KeyCloak, which is our single sign-on social authentication project that we have at Red Hat. So you can write your little WAR file, and we will notice that, hey, KeyCloak is playing along with this, you've set the right properties, and you have a keycloak.json, and so we'll wrap your WAR file with enough stuff to kind of protect your endpoints with authentication. So fractions have a lot of power to them. It's not just subsystems. So here are the ones that we have that are based on subsystems. We have data sources, EJB, JaxRS, transactions, everyone loves transactions, InfiniSpan, clustering, which is not like session clustering as you may be familiar with, but more kind of JGroups clustering. We have Bellabon back here, which is so we can discover, we have 22 microservices running out there, how do they find each other? How do they know who they are? And so we use JGroups to do that kind of service registry. So we have these fractions. Everything is a Maven dependency. You don't have to download anything, you just have to write your pom.xml or a Gradle file. I don't touch Gradle, so can't tell you about it. But we have these Maven artifacts. Everything's org WildFly Swarm, and then a very simple name, JaxRS. I want JaxRS in the version. You throw this into your POM file, and now you have JaxRS included into your application. We also have a plugin for Maven. So I said we have these Uber jars, right? But something has to go and take your WAR file and all the bits of WildFly and jam them together in the Uber jar. Well, we have a Maven plugin that does that with a simple task called package. And it does exactly what we just mentioned. And it pulls in all the fractions you denote through Maven dependencies, mixes them with your app, and gives you out the jar file, the Uber jar. So this is great. I've said a lot of words. But how do we actually convert a Java EE application to use WildFly Swarm? So Lance went and found this Java EE samples app, simple sample. And it's going to use our plugin down here. Because we're using Swarm, we need to use the plugin to create the Uber jar. And then digging around, he noticed that it uses JaxB, or uses JaxRS with JaxB, and it uses JaxRS with CDI, weld. And we have two fractions that map to that. So he just edits the POM file, adds these two dependencies, and types maven.package. And that's it. Now you have an Uber jar that you can run from the command line and email to your friends and buddies and post on Twitter. It's no longer limited to 140 characters, right? I can tweet jar files. Okay. If anyone has questions, by the way, just holler them out. You don't have to wait till an appropriate time. So we type Maven package. Everything in Maven produces something under target, right? And we get myapp-swarm.jar. Our tendency is to take your normal myapp.jar and we add the -swarm suffix to it. It's a classifier in the Maven parlance. So if you do Maven install, it'll get installed into your Maven repository. You do Maven deploy, they'll get sent up to Maven Central or wherever you deploy your Maven things as a -swarm jar in addition to your normal WAR file that you may have been building. Okay, now if I want to run it, I said these are executable jars. Has all of WildFly that you need inside of it as your apps. You just Java-jar it. But that's fantastic, but if I'm developing, I don't want to have to go do a Maven build and then go back to my command line and Java jar these things. So our plugin also supports this WildFly Swarm run, which basically runs your application as though it's a Swarm file. You can add a property saying use UberJar, I believe, that will actually build the UberJar in the background and then run the UberJar directly. Our run kind of shortcuts that and runs things just from disk where they are. Still compile, of course, but like if you're editing like a single page app, you want to make changes to your HTML or your JavaScript, you can do :run here and then go edit your files and they'll load up. So fractions, though, are not just Java EE. I mentioned Keycloak. I love Keycloak. If you're doing any sort of authentication or logins for like against GitHub and Twitter and LinkedIn, or even if you're backing it with LDAP or I think Kerberos even, Keycloak is awesome. If you've worked with social logins before, many times you've had to bring in an adapter for Twitter, an adapter for GitHub, and an adapter for LinkedIn all to your application. With Keycloak, this is just generally speaking, this has nothing to do with Swarm. With Keycloak, you just authenticate against Keycloak. And then Keycloak handles whatever federation back there that you're authenticating against, whether it's your local LDAP store, or if it's Twitter or LinkedIn or whatever. A nice thing about Keycloak too is that it does OAuth, and so it's very standards based. It uses OpenID also, and you authenticate with Keycloak and you get back a JSON web token, which is this nice little base64 encoded JSON, which has everything you need to know all about this person. It includes their roles and what credentials they have, and it's signed, with a public key, so that the server that receives this can verify the signature of this token without ever having to contact Keycloak again. So it's very efficient. You're not making all these repeated calls to Keycloak saying, Bob says he's an admin, is this true? Instead, Bob hands over basically a notarized note saying, I'm an admin, and any service can verify that. Keycloak is built as an overlay on top of WildFly. And so we can do authentication. I'm going to have to come over here and scroll. So this is normal JaxRS. We have a path that matches it to / and then a book, and then it takes an ID. And if you see here, this argument, context, we can inject the security context. which if you include the key cloak fraction into WildFly Swarm, that will be populated for you by the key cloak adapter that looks and intercepts any of these calls. If there's that JSON web token, it's mapped it up to a bunch of objects and a security principal, a key cloak principal in this case. And then you can do stuff with that. And so you have authentication information just by including the key cloak fraction into your Swarm app and adding this injection, standard JAX-RS injection of a context. You can now have access to that stuff within your application or inside your resource here. This is from a demo I will show in a little bit that basically looks to see if you're authenticated. You know, if we have a principal and the principal's not null, the price of something is $9 or pounds, quid. If you're not, then it's 10. So Netflix OSS is something we've worked on here. Has anyone used Netflix Ribbon? Okay. So basic background of Netflix Ribbon is that it's an HTTP client library for the most part that allows you to define interfaces in Java, like a Java interface, like a class, and you annotate it, which then ultimately binds this interface to a service that's running out there. So like we could have in this case, a book lookup service. And so I could do, service.lookup and give it a book ID, and that invokes a RESTful call that then comes back and gives me the data from that call. The cool thing about Ribbon is that I never include the host that I'm calling. I refer to services by name. And I say, all right, I want the book service. I don't know where the book service is. And in fact, there could be 10 instances of this because we talked about scalability, and a lot of people are looking at books, so I run 10 of these out there. We use JGroups to discover where all these are, and we come up with this list of the 10 services that can answer the book query. And Ribbon ties into this. And so I say, Ribbon, give me the book service and look up the book, the price of book number 7. And Ribbon will go and find the list of 10 servers, and it'll pick one. It's called client-side load balancing. The very basic load balancing is round robin. It has the 10 servers, and the first time you ask, it uses number 1, second time it uses number 2, and so forth. You can put in other load balancing strategies if you want. And as services come up and down, that list that's available to Ribbon will change. So if you add 10 more of the book services, then that list becomes 20, and you load balance across them all. If the original 10 go down, that's fine. You don't have to have your client actually care. All it knows is Ribbon will go find it. And this is from Netflix, the people who do the movie stuff. And so here's an example. And all we have to do is create our archive of what we're deploying. And I've actually kind of skipped something here. So in WildFly Swarm, you can build a WAR file, but you can also provide a main method, which is where you set up your container that's running inside your Uber jar, and you can use shrink wrap to build an archive, a synthetic archive in memory of, here, deploy this thing. So you have the same mental model as JavaEE of building a WAR file, but you don't actually have to build a WAR file. So here we're creating a JAX-RS archive using shrink wrap. We add all of our classes to it using the add package bit. We say it's a Ribbon archive because we want to participate in this whole Ribbon magic that's going on. We're also securing it with Keycloak, so we add secured, and then we deploy it. And so this runs when you run your Uber jar, creates this little WAR file with JAX-RS stuff that's secure and Ribbon enabled, and then it deploys it and it runs until you hit Control-C. So one thing we've tried to do with Swarm is have convention over configuration. Anyone who's used WildFly and looked at Standalone XML, it's about 600 lines of XML, 900 of which I don't know what they do, and I don't know how to edit them ever. And 9 times out of 10, the Standalone XML as it ships works, right? It's there. And so what we've done with Swarm is we've tried to basically take all of this stuff and make it so you don't have to have this configuration around. We kind of put in good defaults for you. But we have also given you an API, a Java API that maps to all the things you see in Standalone XML. So if you want to go change the JGroup stack, or you want to add extra cache containers in the Finispan, or add data sources, we now have a Java API where you can go kind of do that with a very fluent API. And we use Java 8 lambdas to make it kind of really pretty, kind of the builder pattern and stuff. And here's an example of where we're adding a new cache container to the Infinispan bits. So we say a new cache container, we set the default cache and JGroups transport, and I think it reads fairly well. It doesn't make for a good bedtime story, but and then you add this fraction, set it up, and start your container. And that's replaced the stanzas of XML inside the standalone XML. A lot of things we've also allowed you to like override the defaults by using properties on the command line or in your Maven file. So if you're going to start doing microservices though with WildFly Swarm, there are some hurdles. And these are kind of anything to do with microservices. If I take a single monolithic app, that's one thing to maintain, right? If I have 22 services and some of them I have deployed 10 times, there's a lot of complexity there. I got a lot of things to keep up with. You know, we use things like ribbon in JGroups so that we can handle if some of these fail and figure out when they come back and be able to take care of all this. But there's still a lot of stuff to keep up with. And that's inherent in pretty much any distributed system that's that large. We have the operational complexity of making sure all this stuff is running at the right time and handling it if it falls over, or you know, if we no longer have one dashboard to look at to determine is this stuff scaling well, am I overloaded? We might now have a dashboard for each of our services, you know, unless you aggregate that, but you got to keep up with all these things, make sure they're scaling the right way. And then tooling. We had a very vivid conversation at lunch today about how we're lacking tooling to kind of unit test microservices. If I have 22 services, do I have to run them all on my laptop if I'm working on number 23 because they're all interrelated and interacting? If I'm building a monolith, I can at least use stubs and mocks and do unit tests. You know, what sort of tooling do we have to help us with testing microservices? This is a slide from someone else's presentation. Every sufficiently large deployment of microservices contains an ad hoc and formally specified, bug-ridden, slow implementation of half of transactions. Our boss is the guy who does transactions for Jboss, so this is the obligatory section of the presentation for him. We support transactions, so JTA or JTS or whatever. I don't really do transactions that much, but we support them. We have a transactions fraction that does everything that Arjuna does, or Narayana, or whatever the name of it is this week. And you can use it from inside your JaxRS stuff. You can begin transaction, you can look up your user transaction, you can commit or roll back or whatnot. This is from an example test that Mark wrote for us. And so I've kind of churned through this, but the future for WildFly Swarm is being defined this week, as we're all in town. But we're trying to figure out when we can do a formal release. We are on Alpha 8 currently. It's been a year in the coming. I do a lot of alphas and betas, and it takes a really big, significant event for me to do a formal final release, but we're going to try to get there. Most of WildFly is currently supported. So for the most part, if you can do it in WildFly, you can do it with WildFly Swarm. That includes JSF, so you can bring it here. We need to improve our integration tests, because currently we have little tests in our example repo that work, but they're not very real world. You know, it's like, let's try hello world JaxRS. Let's do hello world with transactions. Hello world. And so to do all of this, we need also good community feedback from people who actually try to use WildFly Swarm and succeed, or try to use it and fail, or want to use it but it's missing some parts. So now I've done a lot of talking. We're going to see if the demo gods are smiling on you, and I'm going to show you a demo that we've put together. It's called Booker. It is supposed to be like the Amazon Kindle store kind of a thing, where you can go and browse books, and you buy one and put it in your library. It's a single-page app. I wanted to learn how to use React.js, so it's based on React.js for the single-page app. It is secured with Keycloak. Some services, I showed you the pricing one, where if you're authenticated, it's $9, 9 quid. If you're not, it's 10. It does inter-service communication with Ribbon, so that I go look up something in the store then asks the pricing service, how much is this for Bob? And gives me back the price. So that's the browser talking to a service, which talks to another service. And then we also keep up with all these services back to the single page app. So React.js can also speak to the whole cluster of services and knows which services are up and which ones are down. That's the theory. We'll see if this demonstrates. So let's sit down now. Start that. All right, so first, if you want to play along at home, this is on GitHub at wildfly-swarm/booker. And So the first thing we're going to do, this contains a few services that are running. First of all, it's going to run the Keycloak server. And so I'm going to launch that. If you notice, I'm launching with my WildFly Swarm run task. Keycloak actually comes as a WildFly zip that you download and start as a normal WildFly, but we have swarmized Keycloak. So we also just have an executable jar we can run, and that's what I'm using here because it's easy. And as we sit here and twiddle our thumbs, it boots. You see the normal booting that occurs when WildFly boots. And so then to prove that that is now running, we can go to the Keycloak, which is running on port 9090 now. I can log in. It's a normal Keycloak. I can't tell you all about Keycloak, but we have a realm that's defined for Booker, which is this application. I have predefined some users, Bob, Jane, and John. And so we have Keycloak running. So then we said, yeah, let's make sure that's working. Okay. Because JGroups likes to have multicast.
This problem is gone in the latest version.
Is it?
Yes.
WildFly 10?
No more. No word of JGroups.
Oh, well, if
more,
I need a WildFly, man.
Routes, multicast routes.
Yeah, because it's Macs don't like multicast. JGroups love multicast.
It's Mac OS though.
Yeah, it's the Macs problem. But if you notice, that's in my command history.
Yes.
So I said this is React.js app, right? And so one of our services basically just serves up the static bits of React.js. But it also has another fraction called the Ribbon Web App fraction, or we've changed the name actually to Topology Web App. But it's what allows your single page app, your React.js stuff, to connect back to basically a server sent events to keep a kind of a running updated list of all the other services that are running inside your environment. And so initially nothing's running inside my environment other than Keycloak. But if I go to localhost 8080, so here the single page app is running. Anytime I click now, it's not going to go back to the server. This is all client-side JavaScript routing and stuff. And I can go view topology. There's nothing there because there's nothing else running yet, right? So we now have Keycloak running. We have the single page app. So part of what we need to have going is a store, something that keeps up with all the books that our Kindle bookstore here can sell us, right? So I start the store service. And while that's launching, let's go back to our topology. And if everyone prays real hard and thinks happy thoughts, when the store comes up, it will pop up here on the screen. Yep, there we go. So here we used the WildFly clustering stuff with the JGroups underneath. They advertised itself. It went to the web app, the single page app, the server side of that, got pushed through a server sent event and popped up here on the screen. So now I can search the store. So I like Abraham Lincoln. If I can spell him though. Lincoln. There we go. And it loads up the stuff. And so this is the single page app talking directly to a JAX-RS store service that returns a bunch of JSON, which then React.js formats. So, okay, I have a store, but I also need to know how much stuff costs. So let's start the pricing service. This is the one that will use Keycloak information if available and tell me whether it's 9 or 10 quid. And while that starts, let's go back over here to our topology page. Oh, pricing just popped up. Additionally, we keep up with whether the service is bound to HTTP or HTTPS so that we can know whether we're doing a secure or need to do a secure invocation or not. So in some of these registry mechanisms, they're called tags. We just tag each endpoint with the appropriate tag. So now let's go back to the store and I go Lincoln. And let's just look at the first one. It loads, tells me it's $10. All right. Well, I know it should be cheaper than that because I have an account here. So let me go log in. I click the login link. It's throwing me over to Keycloak running on 9090 now, different service. I can log in, throws me back, and now it's telling me it's $9. And the route of this is so my React.js went to the store, looked up this particular book. The store then took the same credentials I talked to it with from Keycloak and went and spoke to the pricing service. And so my security context, my credentials propagated across these multiple calls going over REST and Ribbon to the pricing service, and then it percolated the information back up. So now I can hit purchase now. Maybe. Hey Lance, we maybe have a bug. Okay, that didn't work. Because I'm not running the right service. Yeah. So, I'm going to buy it, right? I got to stick it in my library. My library was offline. So let's go back to the topology, wait for the library to come up. We need some music. Do charades. There we go. All right. So go back to the store. Search for a book. Purchase now. It's purchased. So for this one, the single page app, went to the store, got the information about the book, the price, brought it back to the app. I click purchase, and now the app is talking directly to the library, saying, here, put this in my library. And the library is also authenticated because there's Bob and there's Jane and there's John, 3 different people. We've got to know whose library to put it in, right? And so I have to call that with an authenticated request. And then I can go to my library and I see everything that I purchased. So surprisingly, this app worked, which is fantastic for a demo. So basically, bottom line is that, hey, this is WildFly Swarm. Y'all didn't have many questions, but I will take a lot of questions now because I came very quickly through this. But we're available on GitHub at WildFly-Swarm. We have a whole lot of good docs hosted on Gitbook, so we can take pull requests against them if you find typos or errors. We're on Twitter as WildFly Swarm, and we love IRC. So if you get onto Freenode and go to WildFly Swarm. So the man with the beard in the back had a question?
Yeah, I was going to say, another neat thing is if you start a second copy of the store,
right,
you'll see that pop up.
Yeah, let's try that. So repos, Booker, store. So I'm going to do, you probably can't see this very well. So I go Maven WildFly Swarm run, and then Swarm HTTP port, because everything has to be on a different port, right? Because I only have one interface here. I'm going to do that on 8088. Hopefully I don't have anything in that. So we do that, and we go back to the topology. A second store should pop up here. Hey guys. Y'all must be Americans because you're late. We're deploying a second store service.
Isn't it Jboss HTTP port instead of Swarm HTTP port?
So you should know.
Well, it's Swarm HTTP port. We can change that.
It didn't join up.
Set it as
8088.
using Swarm? Or
Yeah. Yeah.
Okay.
And this is so big I can't see where Undertow's listening. Undertow web context.
Oh, you know what?
8090. Why is it on 8090?
Is it not showing up in the UI?
Yeah.
There's a bug, and I fixed it. It's there. Look at the developer console. You'll see it's there. But the React key
Duplicates.
is duplicate.
Right. So we have a bug in the demo. Sorry guys.
Okay.
But it's here. Yeah, here if you look there. So we have store one on 8082 and one on 8090 because we also set a default port offset. So I did 8088 and then it offset it by 2. Fantastic. Okay. Well, thank you, Ben.
Right below it tells you that child keys must be unique.
Right. So I apparently didn't learn React.js very well, but it's fun. So if I search for Lincoln, it tells us down here which service gave us the results. And this time you see it went to the second one we did. And basically, if I keep on searching repeatedly, you see it's round robining between them.
You could also bring the first one down and then the topology page should change.
That assumes I know which one of my tabs was the store. Web client, pricing. library. So this was my first store, I hope. So topology. Okay, yeah. So now it's only listing the second one. So here we launched one store, brought up a second one, and brought the first one down, and it had no downtime while doing it. It still works. Yes, Bella.
So this looked as if you brought up a few full-blown WildFly instances and talking REST to each other, playing devil's advocate, of course. What's the? I would have expected a much faster startup time because you're only bringing up fractions. Why did it take so long?
Right. So part of the time is the time of deployment. And, WildFly does take some time to deploy apps sometimes. Additionally, if trying to think. We're not running these as Uber jars, so we shouldn't be copying stuff, right?
Well, you're not doing a Java jar, right? You're actually.
You do a Maven WildFly Swarm run.
Right.
So
Yeah, it takes
Maven
That does.
getting to the package pro.
If you do Java jar, it's faster.
Okay. So
Java
let's.
is faster.
All right. So let's try that. Store Swarm jar. One.
Port conflict.
Port, yeah.
It shouldn't
Well,
have
go
used
back to the original port though. So
Oh, this is- yeah, this is the-
Swarm HTTP port 8082.
We didn't specify port to use WildFly Swarm run, so
Yeah,
this
this
is
is
the one that's on the default. I know, but
Here, let's try 8082. Let's see. Here, let's actually try 9097. There we go. 1, 2, 3, 4, 5,
So what is it
Six.
right now? It's copying files.
7. Yeah, and I had a conflict. Really? Right.
Now, typically for me, it just takes a couple seconds.
Oh, you put the -d after the -jar, so it doesn't actually set a system property.
Java-d swarm HTTP port equals 9097 -jar target. What am I store?
Okay.
Booker store swarm. Thanks for playing along, guys. Okay, so this will also be somewhat slow because class loaders do not like jars within jars within jars. And our Uber jar, but here, it was faster, we're done. Okay, so our Uber jar is jars within jars within jars, right? We have the Uber jar on the outside, which is executable. It has your war file inside it, that's your JaxRS thing. It also has a M2 repo, a Maven repository inside that jar file. For all the dependencies that WildFly has, that your app may have, whatever. We keep them organized in a Maven repository. And so we have jars inside jars, and class loaders don't like that very much. And so when we boot an Uber jar, we're actually copying these things out into temp files in your temp directory so that we can deal with class loaders a little easier. Additionally, we have Jboss Modules involved because WildFly is based on Jboss Modules, and sometimes they have artifacts that are inside the module directory. Then we'll have to copy those out to a temp file so that we can actually get to the bits. And then additionally, just when you deploy your own application, Undertow and WildFly, when it deploys, it copies your jar file and it explodes it out into a directory, an exploded war file. So there's a fair bit of I/O that's occurring when you first start this. But it's all in temp files, and 99.7% of it gets deleted when we quit the app. I have a pull request that I need to file with upstream. So, but is that faster for you, Bella?
Yes.
Okay.
So, got a question from the audience.
Okay.
So, so WildFly Swarm version 1.
Yes.
You got any rough ideas when you're expecting to have that by?
Maybe midsummer. I don't know. I don't know.
think just if it's this summer, not next summer.
Oh no, it'll be certainly during this century. No.
Sometime during this year, hopefully.
Right.
Before the autumn.
Yeah. No. I think we're aiming for midsummer. We're kind of discussing even today of what do we need to be complete. What's missing. What do we need to add. What do we need to take away. Because we do support JSF. And microservices and JSF don't necessarily seem to go well together. If you're doing microservices, are you doing JSF? So we may actually remove some things, but we're trying to figure out what more do we actually need before we're comfortable calling it a 1.0.
Okay, I think that probably answers the question. So the next question we've got is, if you want to have the configuration outside of the Uber jar, is that something that you support? So you can change it?
Yes. So we have a couple of methods. A lot of the properties are settable through properties, like you saw me setting Swarm HTTP port. It has the default that gets baked in when you build your UberJar. If you change those properties through your Maven POM, when your UberJar gets built, those properties are copied in. So like in my POM, I could say the Swarm port is the 9090, let's say. And then when I run the UberJar, it will be that port, but I can still override it with properties. So there's a whole assortment of properties you can override. Beyond that, Heiko Braun, who's on the team but not present tonight, has added support basically for standalone XML. So if you're migrating from WildFly and you happen to be fluent in how to write standalone XML and you have one that you've already modified and you like, you could basically take that and feed it to WildFly Swarm now to kind of set up your configuration. There are some limitations to that because there are some bits of Swarm that are not configurable through the standalone XML. I mean, things like deploying Jalakia with every app, things like that. I think maybe some of the keycloak bits. So I mean, there's limitations, but if you have a standalone XML that you know and like, you can basically include that. You write your own main file to read your standalone XML and you feed it into the system or whatnot, and then you can edit that and redo it.
Okay, I think that probably answers that question. And the last one we've got so far is it possible to deploy an external WAR to WildFly Swarm?
Yeah, so Ken and I have had this conversation many times, and it's one of those things that we could probably accomplish in half a day's work. We just haven't done it. Because we do provide, or you can provide your own main file, right? Or your main method. We have a .deploy that takes a shrink wrap archive. I mean, it's like 4 lines of code to read your main args, import those, whatever's mentioned there, as a shrink wrap archive, and then deploy it. I mean, it's a very trivial type of thing. You could do it on your own, but we would like to be able to actually provide a way to do that easily without having to write your own main.
Got it. So it's probably something that's going to be in one final then. Something you would expect to do that.
What's the use case? I'm very curious to see what the use case is.
So one use case might be if you're doing Docker stuff and you have, let's say, a lot of microservices that are all, let's say, JPA and JAX-RS. Okay, you have a very common set of fractions you want to include on them and you're using Docker. So I want to build a deployment-less Swarm jar, an UberJar that doesn't actually have any deployment in it. And I want to lay that thing down with just JAX-RS and JPA onto a Docker layer. And then I want to layer on top of that my 22 different WAR files that do whatever JAX-RS and JPA that they specifically do. And then they're fed as an argument to the one layer down on your Docker container stack.
Makes sense to me.
Any more questions?
Yeah, so the next question is, so can you include an admin fraction, which would allow you to use the CLI to configure?
Yes,
Swarm?
yes you can. Yes, so we have the management fraction is what we call it. It's what you need to do when you're doing security realms and setting up SSL in the first place, but you can also then enable the HTTP endpoint for Jboss CLI, and you can start your Swarm process and then Jboss CLI and type connect and connect to the right host and port or whatever, and you can manage it. One caveat with that, though, is that Swarm process is immutable. So you go in and you change thread pools or you do whatever you do, we're not going to write that back out. We're not going to persist it. Where in a normal WildFly, you make a change, it will go scribble your standalone XML for you.
Yeah, so maybe useful for debug then, if something's going a bit funny, or you want to just try something out quickly before you commit it to before you want to actually go and configure it properly.
Right, and the one thing like John wanted was to be able to at runtime change log levels. I want to go in and turn on trace for J groups because it doesn't like my multicast on my Mac or whatever, and see what it's doing. You can Jboss CLI into the logging subsystem and do that. Or you can tweak thread pools to see, it performs better if I have 6 threads instead of 22.
Yeah, makes sense.
How does this compare to Vertex?
I don't even understand the question. How does JGroups compare to WordPerfect? I mean, no. Yeah, so no, Vertex is a perfectly viable way to do microservices. The differences that I would say is that Vertex has its own ecosystem. It's a whole new mental programming model. I mean, it's all asynchronous by default. While you can bring in other jars, they have their own Vertex module system, which may have gone away with Vertex 3. Do we know? Okay. But so Vertex is just a new kind of fully asynchronous way to do stuff. It would be more like Node.js. which is great. It has this event bus, which allows you to communicate asynchronously between different services and not care about where they're located. I mean, it solves a lot of problems. But you can't use your Java EE knowledge. I mean, that's by design. But if you know JAX-RS and JPA, you're going to look at Vertex and go, eh, you know. So this is mostly meant to kind of address microservices from like the Java EE kind of clientele. People who are familiar with it, but are tired of running the big app server.
Good. Another question. So, why is everybody talking about Spring Boot and not WildFly Swarm?
They've been around longer.
Yeah, they've been around longer. They have Josh Long, who I don't think is ever home. I think his pet is a fern because he's always traveling. No, they've done a good job, and they spend a lot of time and money doing promotion and evangelism, and they've been around longer. So, but we're going to change that. I have a nicer hat, so I'll do it.
Good stuff.
Any other questions, online or off? No? Hey.
This might not be so specifically related to WildFly Swarm, but you mentioned earlier that you were talking about the fact that you didn't have the tooling to do unit testing of microservices. In passing, said that you can't really do mocking or anything. But I mean, why could you not quite simply mock, and remote service? Produce a mock. And there might, if you have a really complicated setup with lots of microservice components and they've got a topology where they depend upon each other, and I understand that there might be a little bit of effort to build something robust for testing microservices there, but to do simple integration testing on microservices, surely the tools exist.
Right. So I mean, you certainly could mock it. I mean, you could build basically a duplicate service, listens to HTTP or whatever, and that returns very canned responses or whatever. You can mock that. One problem is though is that if you then change your real service, did you keep your mock up to date, or is it answering the old API? If you've changed added fields to your JSON or whatever you're returning, keeping those in touch or keeping those up to date can be difficult. There is an example in our repository that Heiko Braun did. Is it contract? No.
Consumer-based.
Consumer-based.
No, consumer-driven.
Consumer-driven testing. So it's basically you set up this process between two real services and let them talk to each other for a while, and it learns, all right, here's what you guys are talking about. You normally ask this, and you normally respond with something of this shape, and then that can then produce a mock for you for that service. But that kind of involves having two live services and having to observe empirically what's going on there. And another issue though, kind of going back to my first objection, is that how do you keep your mocks up to date? Well, in a microservices world where you have different release cadences for all your services, you kind of always have to maintain backwards compatibility, or if you change it, it's actually you're adding another service, because I can't just one day decide I'm going to change the book service because there are 21 other services out there that depend on me, and I can't tell them they have to update today. Even if I do my continuous deployment and I stand up a new one, they're not expecting this. I can't force them to. We did not release in lockstep everything. So I have to have version 1, I have to have version 2, or some sort of versioning method and some way to instruct these guys, all right, when you do update, why don't you start using version 2, and then I got to pay attention to see if anyone's using version 1 anymore, and maybe then I can finally take it down. And then there are products like API Man, which is kind of a gateway that sits in the middle that might help kind of direct this traffics, but these are other problems we get when we no longer have tightly coupled software. This tightly coupled software, at least, I hit Command F9 on IntelliJ and it tells me this doesn't compile. You're wrong signature, and I can go refactor that. Google has a single giant repository for all of their code because they want everyone to refactor everything all the time. But when you have loosely coupled services, you've got to assume someone's going to keep calling your old code forever. I think Fielding says just in his REST document that you never retire a URL. A URL should always be around. Version 1 of your service needs to live forever because you never know who's going to wake up on Tuesday and call it. And so this takes a different mindset of architecture to be able to accommodate that. And this is something that's not just microservices, but anything that's loosely coupled and network enabled and different release schedules. How many people does Twitter break if they change their API? They have to keep the old one and introduce a new one. There are rules where you can have backwards compatible changes, If all you're doing is adding fields or adding extra operations, as soon as you take something away or change its name or take one object and turn it into 2 resources, well, you're going to break somebody's client, and especially if it's an unknown, unbounded set of clients. You have to protect against that.
Got one more.
Oh.
Go ahead.
Am I right in thinking that if you swarmify your application, it'll increase slightly the memory footprint of it, so all the extra classes should be loading in?
So I think it's basically you break even, because it's going to be fewer jars than WildFly would be. Like if I, WildFly as it is with everything, includes everything. And a swarmified one will have fewer jars, fewer classes than, I don't have transactions in this one. So, I'm saving a few bytes on disk. Disk is cheap, right? Then if I launch it, am I saving anything in runtime memory? I don't think particularly. I mean, there may be some class loading space, but in the general, WildFly is very lazy to load stuff. The JVM is lazy. Just because it's on the class path doesn't mean it's loaded into memory. And WildFly will even set up services that it won't start until someone needs them. And if your app never needs them, they just sit there idle, and they're not really, you haven't wasted this time and effort booting up Corba or anything. So I don't think it's that much of a savings. I know if you go read the blogs about Spring Boot and everything else, people are like, oh, this is 16% smaller or whatever. But I think it's a pointless argument to make. I think what you're gaining here is just a different mentality, a smaller surface of things to think about. Your Uber jarness, those kind of things I think are the important aspects of this, not how much space on disk. The disk space could kind of be important if you're doing a CD, CI pipeline and you're trying to move this artifact, a lot of different places. But networks are fast, I'm not too worried about that.
So, got another question for you, Bob. So, I'm not entirely sure I fully understand the question, but they're asking about JCA support, so for third-party connectors. So I think what they want to know is if you've got a third-party connector to connect to something that was not envisaged when WildFly was developed, or something proprietary like maybe SAP or something, how would you include that in with your Ruby jar?
Right. So let me preface this by saying I'm pretty ignorant about JCA, but we do have a JCA fraction. It's in there. It's used by some things. I don't know why we added it, but we added it because somebody needed it. Data sources? Okay, that's JCA. So there's that. More specifically is that we use Jboss Modules, and so if you need to bring something in at the Jboss Modules level, you can include that in your app. So like your project that builds the Uber jar is Maven, so source main resources. If you have a modules directory that has modules underneath there, module XML that are used by Jboss Modules, we will shuffle those into the Uber jar for you. So that's one way that you can bring in SQL drivers, JDBC drivers. You can install them as just h2.jar and deploy that, as you can, or datasource.xml. I get confused. But you can also do it by way of modules, like for the Postgres driver or whatnot.
Yeah. So basically, it's just the same way as you would in traditional WildFly server. You create a new Jboss module and off you go.
Right.
Yeah.
Untested, but yeah, let's say it works.
Okay.
So what you have here seems to me to be equivalent to Docker for the enterprise Java world. Do you have the equivalent in Kubernetes? Do you have the orchestration piece?
So there are parallels as far as it being like Docker. I don't think it's mutually exclusive to Docker. I think you could make your Uber jar and then put it into Docker. As far as Kubernetes, I have to admit ignorance as to exactly what Kube does. I hear it mentioned a lot. I know the Fabricate guys like it. But in general, we don't have anything to orchestrate the running and stopping and starting of all this. So maybe Kube is that thing. We do use JGroups for discovery if you have multicast. But we've also kind of abstracted the kind of discovery bits out so that Ben's working on making it so we can use the Kube APIs to do discovery. We have support for HashiCorp's console for doing discovery, so all these services can register themselves there instead of using JGroups to do it. You can also, of course, use JGroups to register them in S3 or somewhere like that, using all JGroups as ping options, including kube ping, right? Yeah. So, no, we don't have anything specifically for kube. Okay.
Any more questions?
Yeah.
Oh, 1 second. Okay, so they're just people in the chat are just saying thank you very much. Lots of good feedback for WildFly Swarm in the chat as well. And someone's saying that they're just talking about mailing lists and so on. So okay, well thank you very much, Bob. Great talk.
Like my hat?
Pardon?
Does anyone like my hat? Thanks. Final clap.
They probably say
But thank you guys for having me here. I appreciate it.
thank
And
you.